Let's look at one more example of applying the 68, 95, 99.7 rule. We have a machine that fills 12-ounce cans of soda. The fills are normally distributed with a mean of 12.1 and a standard deviation of 0.2. So here's my mu and my sigma. I want to know what weight of cans covers 99.7% of the distribution and what percent of soda cans weigh less than 11.9 ounces. Now we're told in this problem that the distribution is normally distributed. So the first thing we should do is draw a picture. I'm going to draw a normal curve, and let me try to do this one more time. Okay, your curve doesn't have to be perfect. In the middle, we're going to mark the mean. The mean here is 12.1. And up top, I'm just going to write a note here to remind myself that the standard deviation is 0.2. Now to the right, I want to mark the points that are 1, 2, and 3 standard deviations to the right of the mean. That means I'm going to add 0.2. So I'm going to have 12.1 plus 0.2. That gives me 12.3. I'm going to add 0.2 again to get 12.5 and then 12.7. And to the left, I'm going to subtract 0.2 3 times. So 12.1 minus 0.2 is going to give me 11.9. And then I'm going to subtract 0.2 again to get 11.7. And one more time to get 11.5. So I've marked all the points that are 1, 2, and 3 standard deviations away from the mean. All right, the first question wants to know what weight of soda cans covers 99.7% of the distribution. Well, 99.7 is the third number in our rule, and the rule says that if I go out 3 standard deviations on either side of the mean, so 1, 2, 3 standard deviations to the left and 1, 2, 3 standard deviations to the right, this is going to contain 99.7% of the data. All right, so what weight of soda cans covers that? 11.5 to 12.7. So 11.5 to 12.7 ounces. What percent of soda cans weighs less than 11.9 ounces? So here's 11.9, and I want the percent of soda cans that weighs less. Less is to the left, so I'm going to shade the region under the curve to the left of 11.9. This is what I want to know. What percent of soda cans is to the left of 11.9? Now 11.9 is 1 standard deviation away from the mean. So using the 68, 95, 99.7 rule, I know that between 11.9 and 12.3 is 68% of my data. All right, now just like before, this green tail and this tail over here are both 1 standard deviation away from the mean, going off to the right or off to the left. And so they need to be the same value by symmetry. And we know that they have to add up to 100 minus 68, which is 32. So that means that this left tail must be 100 minus 68 divided by 2, which gives me 16%. So 16% of the soda cans weigh less than 11.9 ounces. What if I asked you instead what percent of the cans weigh more than 12.5 ounces? Well, if I look at my picture here, oh no, that was big. Let's undo that. Let's just erase a little bit. Okay, so I want to know something about 12.5, and I want more than 12.5, so I'm going to shade the region to the right of 12.5. These are values that are greater than 12.5. So this is what I'm interested in. 12.5 is 2 standard deviations away from the mean. 1, 2. So I know that if I go 2 standard deviations to the right and 2 standard deviations to the left, that's 11.7, this is going to have 95% of my data. All right, the tails by symmetry must be equal here. So this tail and this tail must have the same percent. And they must add up to 100 minus 95 in this case, so 5%. Now, since they're equal and they add up to 5, then what I'm going to do is I'm going to take 100 minus 95 and divide by 2. That gives me 2.5%. So 2.5% of the cans weigh more than 12.5. Here's a question for you. What percent of the cans weigh less than 12.5? See if you can use the picture to determine the answer to that.